Chapter 9, Materials, Part 1 of 3. The questions that we're going to answer: how do soft woods differ from hard woods? What are different categories of ceramic materials? How do thermoplastics differ from thermosetting plastics? What's the difference between a matrix and reinforcement within a composite material? Metals. Metals form the majority of the known elements in the periodic table, and they are arguably the most important materials to the development of modern civilization. There is a difference in the use of the word metal between the fields of science and engineering. In science, metals are pure elements as identified in the periodic table. In engineering, metals is used as a generic term that encompasses all metallic substances, both pure and alloyed. The term metal will be used in an engineering sense to describe a solid material that is typically hard at room temperature, usually 20 degrees Celsius to 25 degrees Celsius, is shiny and possesses good thermal and electrical conductivity. Ferrous metals. Metals are divided into two categories: ferrous and non-ferrous metals. Ferrous metals are those that contain iron. The chemical symbol is Fe. A major drawback to most ferrous metals is corrosion. Iron bonds with oxygen, the chemical symbol O, which is readily available in air and water. This causes ferrous metals such as steel to rust when they are exposed to an outside environment. Elements such as nickel and chromium are alloyed with steel to produce a corrosion-resistant metal called stainless steel. Iron. Ancient metal workers in Egypt and Sumeria were the first to create artifacts from iron around 4000 BCE. However, the iron they used came from the meteorites. Smelting is the process of extracting a metal element from an ore by the application of high sustained heat in the presence of a fluxing material such as limestone. The earliest evidence of iron ore smelting dates back to 1200 BCE in the areas of India, Turkey, and Eurasia. This date in history marks the beginning of the Iron Age. Chemical engineers also use iron in applications such as dyes, pigments, and fertilizers. According to the United States Geological Survey, more than half of the world's supply of iron ore comes from China, Brazil, and Australia. Iron exists as iron oxide in various minerals such as magnetite and hematite. Collectively, these minerals are referred to as iron ore. Iron ore is then pulverized and mixed with coke. Coke is a low-sulfur bituminous coal that has been baked to remove water, coal gas, and coal tar, leaving mostly carbon. The iron ore and coke are then smelted in a blast furnace, which causes the oxygen atoms to separate from the iron atoms. The result is molten iron and unwanted impurities called slag. Slag is comprised of undesirable elements that are also contained in the iron ore rock, such as silicon, phosphorus, aluminum, and sulfur. The slag floats on top of the molten iron, making it easy to separate and remove. Casting iron requires a temperature of approximately 2,800 degrees Fahrenheit. The Chinese were the first to cast iron at around 300 BCE. An alloy is a mixture of the two or more elements, with one of those elements being a metal. If iron is alloyed with less than 2% carbon by weight, the result is a material called steel. Steels are divided into two categories: plain carbon steels and alloy steels. Mild or low carbon steel contains 0.05% to 0.03% carbon by weight. Cold rolled steel is a common type of mild steel that is cheap and often used in the fabrication of machine components that do not require great strength. Medium carbon steel is stronger than low carbon steel, but it is also more difficult to machine, bend, and weld. Medium carbon steel contains 0.3% to 0.6% carbon by weight. High carbon steel contains 0.6% to 1.5% carbon by weight. It is harder and more brittle than low and medium carbon steel and is known for its ability to hold a sharp edge. Alloy steels are manufactured for special purpose applications and are made by combining plain carbon steel with elements such as chromium, cobalt, manganese, molybdenum, nickel, tungsten, and vanadium. This process increases certain properties such as tensile strength, hardness, machinability, wear resistance, and corrosion resistance. Non-ferrous metals. Gold. Non-ferrous metals are simply those metals that do not contain iron. A precious metal is one that is relatively scarce, a highly corrosion resistant, and valued for its color, luster, and malleability. Gold is one of the best conductors of electricity, which is why it can be found as coating on the electrical contacts of circuit boards and other electronic components. A malleable metal can be shaped or formed without breaking up by means of hammering or some other application of pressure. Silver. Silver has the highest optical reflectivity of any metal and is used as coating on glass and other media to generate mirror surfaces. Copper. The oldest known native copper artifacts were found in what is now modern-day Iraq and date back to around 9000 BCE. Archaeological evidence shows that the smelting of copper ores took place as early as 5,000 years ago in the region known today as Thailand. Copper is used extensively in devices that conduct and transmit heat and electricity. Ductility is a property that allows copper is the second best conductor of electricity and is used extensively through the electronics industry. Non-ferrous metals, bronze. Around 4500 BCE, a new type of non-ferrous metal alloy was invented that used copper as its base metal. Called bronze, this copper alloy consists of approximately 10% tin. Cassiterite is the mineral that is used to extract tin. Bronze ushered in a new era of human civilization that lasted from approximately 3300 to 1200 BCE. Bronze forms a layer surface of layer of oxidation that protects the metal underneath from further corrosion. Brass. Brass is a gold-colored, copper-based alloy that is very easy to machine, can be polished to a high sheen, and is often used to decorate hardware such as doorknobs, locks, and hinges. The principal alloying element in brass, as much as 40% by weight, is a bluish-gray metal called zinc. Brass is more difficult to produce than other copper-based alloys because of the difference in melting points between copper and zinc. Copper is roughly 2000 degrees Fahrenheit, and zinc is roughly 800 degrees Fahrenheit. Recent archaeological evidence shows that brass was being made as early as 1500 BCE. The majority of historical brass artifacts date back to the Roman Empire. Aluminum. During the mid-1800s, aluminum, in its pure form, was worth more than gold because it was very difficult to extract from various ores. Elements such as copper, zinc, magnesium, manganese, lithium, and silicon were added to aluminum to improve its physical properties. Aluminum is also applied in situations that call for good electrical and thermal conductivity, corrosion resistance, and where highly reflective surfaces are required. Titanium. Titanium is a metal element that has been known for more than 200 years, but has only been used in engineering applications for little more than a half-century. Titanium alloys are some of the most expensive metals available. Despite their high costs, titanium alloys are growing in application because of three exceptional qualities. They have a high resistance to corrosion, they have a high strength to weight ratio, and elevated temperature performance. That ends part 1.